Hello everyone, today I'm gonna do an example question on calculation of rate law. Okay, so this will be, we will have the concentrations and we'll have initial rate, and then we'll be able to figure out based on different trials or different experiments, and then we'll be able to calculate the reaction orders with respect to each reactant. Okay, so therefore, for this type of question, you're gonna start off looking at this reaction, right? So this reaction itself, you go, well, what the rate law should be. Okay, so the rate law for this reaction will be the rate equals to K, will be rate constant, okay, times the concentration of H2O2, okay, and I will say the reaction order will be X. Then I have the concentration of I minus, the exponents will be Y, reaction order will be Y, and then H plus, the reaction order will be Z. Okay, or you can use A, B, C, you can use any symbols you want, but represents an unknown. That's some number we don't know yet, and then we're going to calculate throughout these based on all this data, experimental data. Okay, so then the other thing is you go, what about this 3 and this 2? Are we supposed to use them? Again, remember, this is the overall reaction. The reaction order will be this one, right? So let me use this color. So that X, Y, and Z, you can only determine all these values based on what? Determine this X, Y, and Z through experiments. Okay, and then all this over here, those are experiments. Okay, so we're gonna base on these values and then actually determine those. Okay, so those coefficients, they're now useful. Okay, so now let's look into that. Okay, so for let's start from the first question. The first question is asking, what's the reaction order with respect to H2O2? So that means you're gonna determine X first. Okay, so I'm gonna use a color for X. Okay, so you're gonna determine X first. Okay, and then you go, what should I do? Okay, so this requires you know the thought process. Okay, so in order to solve for X, okay, we're gonna keep, let me see what's it. Okay, we're gonna keep I minus, okay, the concentration for I minus constant. Okay, so therefore you should go, which one's the constant, which one are not changing. Okay, so we go, that 2, 3, and 4. Those 3 could be my options. Okay, and then you go, I also need to keep this hydronium ion H plus constant. Okay, so you go, which ones are my options? 1, 2, and 3. Those 3 could be my options. Okay, then you go, if my goal is to keep both constant in order to figure out X, okay, in order to figure out what's the reaction order with respect of the first reactant H2O2, and to keep both I minus and H plus constant at the same time. Okay, so which means the overlap will be, yes, the overlap will be 2 and 3, because under this set, right, under this data set, okay, under this situation, you will have these 2 constants, so that means they could cancel out. These 2 constants, they can cancel out, and then these 2 are different, perfect. That's we need that number to do the calculation. Okay, so in order to figure out the first situation, we'll use experiment 2 and 3. Okay, and then we're gonna set up the relationship. Okay, so the relationship is going to be true with respect of this overall reaction. Okay, so then we're gonna go, what's the rate? I'm gonna start with rate of 3. Okay, will equals to, right, will equals to that relationship, K times all that. Okay, and in order to save some time, I'm just gonna strictly plug in the value because we know the actual number. Okay, so that K times 0.2. Okay, now I can get rid of that parenthesis because I already have the values. Okay, and then times that'll be X okay, and it will be 1 times 10 to the power negative 3 times y. Then I have 1 times 10 to the negative 2 times z. This equals to what? I know the actual value will be 0.542. Okay, you can use a unit, but at this moment it's fine because all the units will the units will cancel out. Okay, and then we'll do rate 2 equals to what? Same way, right? K times 0.1 to the power of x, 1 times 10 to the negative 3y, 1 times 10 to the negative 2z equals to 0.268. Okay, so that's what I have. Okay, and then go, how do we solve? We have two equations. Okay, so we're going to use equation on the top. Okay, so we say, I don't know, let's give it equation A and equation B. Okay, so I'm going to use A divided by B equal. How do I divide the equations? Simply, you're going to divide things on the left side and do that. Okay, so therefore, I'm just directly changing on my writing. Okay, so I'm actually just going to add a line. Okay, so that they're dividing by each other now. Okay, so I'm just going to quickly remove that. Okay, and then on the other side, they can divide as well. Now, this just equal. Okay, so you can do that. Okay, so once we have changed the equations into this format or change into this, then we can cancel things out. K got canceled out, this 2 got canceled out, this 2 got canceled. You go, how come? Because that's what we designed, that's what we looked for, right? We look for this to be constant, and that's why we pick this two. Then they can cancel out. Same thought process. We did that. Okay. So they do cancel out. Perfect. Okay, and now we can solve it. Okay, so from this point, you can put the numbers in the parenthesis. Okay, to the power of x equals 2. You do put those into your calculator, that gives us 2. Okay, and then on the left side, I have 2 to the power of x equals to 2. Then x will equals to 1. Okay, so that will be the first step. Okay, so you solve for it. Okay, so then we can use the same logic and to figure out why. Okay, so why we're using orange. Okay, so now I'm gonna erase whatever is over here, then we'll relook at this relationship. Okay, so now let's again think about it. If we're using the same logic, okay, so what are we gonna do? Earlier, right? So we said we're trying to figure out x. Okay, not anymore. We already know what x is. Okay, we're trying to figure out y. What the thought process will be. We need to keep H2O2 constant. Correct. I'm gonna keep this constant. So what are we looking for? Yes, the values is not changing for H2O2. That's convenient. First two. Okay, and then we also need to keep what this. What was the color I was using for that one? I don't know. So we'll do with this. Okay, so for H plus, we need to keep it constant. And then we really, let's check 1, 2, because that's pretty much the only option we should have. Okay, and then that works out. Okay, so therefore, in order to figure out I minus, we need to pick the first two experiments. Okay, and now we're going to set up the same thing over here. Okay, so over here for the second step. Okay, so we're going to pick experiment 1 and 2. Okay, and then we'll do rate of 2. Okay, well, equals to what? The same thing, right? So equals to k. Now just plug in the values. Will be 0.1 to the power of x. Actually, I already know x is what? X is 1, right? So we can start to put that in. That's fine. Okay, and then you'll have 1 times 10 to the negative 3 as y, and you have 1 times 10 to the negative 2 is z equals to 0.2268. Okay, so that's what you have. And we can calculate the same, so you have rate of 1 equals to k times 0.1 to the power of 1, 5 times 10 to the power negative 4 to the y1 times 10 to the power negative 2 to the z equals to 0.137. Okay, and now we'll do the same calculation. I'm going to use the one on the top divide one on the bottom. Okay, so remember what we did earlier? Yes, we can just add a line between. Okay, so that will be division, and then same over here, that equals 2. Then you're dividing that. Okay, so again, that cancels out, that cancels out, that cancels out. We just have whatever left over. Okay, so then you have 1 times 10 to the power negative 3, and then you have on the denominator you have 5 times 10 to the power negative 4 to the power of y equals to about 2. Okay, in this case you can round if the values are very close to a whole number. Okay, and then on the left side you also have 2 to the power of y equals to 2. Okay, then y just equals to 1. Okay, so then you figure out the second one. Okay, and then you go, let's use the same logic to figure out the last piece. Okay, so the last piece we're gonna use, I think, okay, so we'll use z. Okay, so you can figure out z. Okay, so let me erase whatever we have and try to use the same logic. Okay, so the logic will be you're gonna keep H2O2 constant. So you go was 1 and 2. Okay, and you also need to keep I2 constant, but 1 2 they don't match. Then you go what should I do? What should I do? I don't have other options. Okay, then you go but I could do something. Why? Because you already have the order of reaction order of x and y figured out. Don't forget about that. This something you figure out, that's yours. You already know what it is. Remember, what's the x value? Yes, the x value we know is equals to 1. Let's swap it. What's y value? Is also 1. Okay, so let's do that too. Okay, so you have 1 and 1. So those two values, information you calculated, you can use them. Okay, so now you have those, and then I think things are way easier, right? Since you know both values, really it's fine. You can just pick 2 experiments as long as you have H2, as I have H plus are different. Okay, so then which 2's are different? Of course, 1, 2, 3 are the same, but you can pick any one of those, and then with the last one, then it will work. Okay, so that's due to convenience. It will be convenient. We'll just use the last 2. Okay, so use last 2. Okay, and now that's what we're gonna do. Okay, so we'll use let's see, we'll use 4. Okay, so we'll do rate of 4. Okay, so remember k we don't know, but we do know this is 1, right? Okay, times 1 times 10 to the negative 3, 1. Then you have 2 times 10 to the power 2 to the power of z. Okay, which equals 1.084. Okay, we can also do rate 3 equals to k times 0.2 to the power of 1, 1 times 3 to the power of 1, 1 times 10 to the power of negative 2 to the power of z equals to 0.542. Okay, so once you have this, again, same logic, we're gonna do a division. Okay, so then let me change the color. Okay, so you're gonna do a division like that, then equals 2. Okay, and then let's cancel things out. Again, that cancels out. This cancels out. You go, now what do I do? It's different, but don't worry. These two values you know. Actually, we can just do a calculation. When you do a division, what is it? 0.4 divided by 0.2. Yeah, that's just 2. And now you can do that. 2 times 10 to the power 2 divided by 1 times 10 to the negative 2 to the power of z equals 2. That's 2, right? 2 get cancelled out, so actually you'll get 2 to the power of z equals to 1. And then you go, this is something I'm familiar with. Z needs to equals to 0 in order for this relationship to work. Okay, so now you have all 3 reaction orders. Okay, then you go, am I done? No, unfortunately, right? So there's a one more step asking what's the rate constant with its unit. Okay, and then you go, what do I do? As we said, you already know all 3 values. Okay, so now let's bring this to the last step, so we can use use it to do the calculation. Okay, so you already know this, and now we know z is 0. Okay, z is 0, actually that whole piece over here just turn into 1, so then we can just cancel it. Okay, so this will be the rate law for the overall reaction. We're trying to calculate K. Okay, and then you can use, as we said, any set of experiment. I'm gonna use 1. Okay, so then we'll have the values plug into the equation. You go, how do I plug it in? Okay, so that's, you can, let me bring this so you can see it. Okay, so I'm gonna use 1. Okay, so we're gonna use this. Okay, we're gonna use this to do the calculation. Okay, so you have the rate equals to 0.137. Now I'm gonna use a unit so you can see how the units come out as. Okay, in the case something we don't know, they have 0.1 molar. Okay, and then you also have 5.00 times 10 to the negative 4 molar. Okay, so that's what I have, and then you can do the calculation. Okay, so you can use 0.137. So let's actually do it. Okay, so K will equals to 0.137 molar per second divided by 0.1 molar times 5 times 10 to the negative 4 molar. Okay, so you do the calculation. You see, molar got cancel out 1, and then let's do the calculation. Okay, so let me actually do it real quick. So you put that into your calculator. Okay, so the answer comes out as 2,000, about 2,710. Okay, so that will be the answer, and the units should be what? Should be molar to negative 1 second to the negative 1. Remember a shortcut we mentioned before, right? Okay, so of course that shortcut is saying if the units for time is second. Okay, or if it's minutes, but minutes still be just, if it's minute, it will be molar to negative 1, minute to negative 1. But the shortcut actually itself is what? Is molar to the 1 minus n as to negative 1. Okay, so that n represents what? The overall reaction rate. So the overall reaction rate for this reaction is what? Is 2, because it's 1 and 1, right? Okay, so it's 2. If you plug 2 inside this shortcut, okay, so that actually turns back to the units we just mentioned. Okay, so then you go, well, I don't like the shortcut. It's fine. You can just do the algebra and then figure out with this relationship. Okay, so it also works out. Okay, so this is the end of this video, and hopefully this is helpful. And then make sure you understand the logic. Once you get the logic, doesn't matter what type of question you run into, you always know what to do. Okay, and then thank you for listening, and hopefully this is helpful.